Hello and welcome to sixth stream of me building a air-gapped BIP44 HD Crypto wallet. We Let's jump right into it. We were able to get to the point where we were working on the prepay send transaction handler. So let's continue with that. I'll just quickly open the chat windows. Let's pop this chat from here. Make sure it's indeed up and live. Cool. Okay. Okay. So we were at this point where this endpoint will receive what transaction needs to happen from the client side, which is the wallet app in here. So we are building the handlers for the backend server here. And till now, we have built the load handler, the add account handler, the generate address, and the broadcast one partially. The only part remaining in the broadcast handler is where we are supposed to send out the sign transaction for broadcasting via the JSON RPC call. But since we are not running a full node right now and we are using the API provided by blockcipher.com, I have not gone forward with that just yet because currently I'm only using it to fetch the balances of the addresses that I need to know. And this API might as well support that. Should be a straightforward thing. And if not, then we'll figure out. But for now, I've left it, and I'm working on the. I was working on the prepare send transaction in the last stream yesterday. So let's continue from that and see how far we can get today. So from the client side, the wallet app, it will essentially give us the account ID from which the funds should be used for the transfer, the recipient address, the amount that the user wants to transfer, and how much fees are they willing to uh, spend in the broadcast of this transaction. So for now, we simplify the case that we are simply treating fees as just a flat fee, and we're not complicating it with any fees indicator, fees estimator, or what the appropriate fee should be, depending on how fast the user expects this transaction to go. So we are simply considering it a flat fee for now, and then we'll later evolve that into an elaborated fee calculator of some sort. So over here, let's see what we were trying to do. We connected to DB to get the index value. Okay. Um, Maybe it's from the function copy that we copied earlier. Yeah. So we are only at this point right now. Wait a second. We are here. Okay. So what do we need to do? We we have the information that we need in order to build up the transaction in the unsigned format. But let's look up what the unsigned transaction actually looks like. I have no idea how that looks, so let's figure that out. Oh, come on, DNS. This seems to be up. Okay, let's see. How to sign a transaction. This could be something that we need. I think it is possible to generate keys on an offline computer and sign. That's correct. To create a transaction, I need to input transaction details. And somehow I have to transfer signed transaction from offline computer to an online computer to relay the transaction. Is it possible to do this without using USB storage? I can use a keyboard or a barcode reader to transfer the input transaction hash to an offline computer and the signed transaction back to the online computer so that private key stays with the offline computer. What are step-by-step instructions to do this? This guy was build wanting to have the air gap concept of the vault, essentially the same concept that we are working on back in 2013. I'm just curious to check out. He seems to, okay, he's from Singapore and the account doesn't exist anymore. Wow. Maybe he's a whale now, who knows? Okay. The answer is you're correct that the offline node needs to claim its funds, so it can't be totally isolated. Currently, the most mature offline wallet solution is through a client called Bitcoin Armory. Here's what your workflow looks like. Online nodes create transaction, USB key. Offline computer signs transaction, USB key. Online node broadcast transaction. Okay. So in our air gapped wallet system, we're essentially doing the same thing, but instead of relying the USB key, which requires the user to plug a USB drive and copy the unsigned transaction onto it and then take it to the air gapped computer. This is essentially beats the air gapped concept in a way that they could be the transfer of a malicious program in the USB drive as well. So that is why we're restricting the communication between the wallet and the vault by only using QR codes and nothing else, so that the air gapped wallet truly remains air gapped. Okay, they are only talking about the concept of it, but not how the like no information on how the unsigned transaction actually looks like. Perhaps it's mentioned in the Mastering Bitcoin book somewhere. And essentially, what we want to do is this account ID is essentially an account in an HD wallet. So it's not gonna be the case that the input of the transaction where the funds are gonna be debited from, like the addresses from where the funds are gonna go out. It's not a single address. So we also have to scan the account for the addresses that are in there and aggregate all those addresses and see how many addresses do we need to be able to fund this transaction of this amount along with the fees. Um, I do remember doing something in this regard. I think this was it. So why is this not relevant? Let me jog up my memory. Why were we trying to get the index value here? Get account details. Okay, we needed this for the expub key and for anything else. So we fetched the entire account row. We put that in the account variable. And then, okay, first of all, we were making sure that it wasn't, I mean, like, why did you fetch the index then? That doesn't make sense. Oh, this is just a, damn it. We're simply connecting to the database here. We're not fetching any index. That was a wrong comment. This comment was something like this. Need to get index value from DB. So we connect to DB and then so on. So now we are back in this. Let's see why. Okay, it's saying we have not used it. We can ignore that for now. We fetch the account, then we first of all ensure that the account is not a watch only address, and the private key for this account is indeed in the vault, because essentially this wallet app can be used independently of this vault app as well. You can monitor any address or any HD wallet or HD account, an account from another HD wallet here as well, without relying on this, just to monitor funds and whatever. So even if you are not using the entire system and you're relying on a hardware wallet of Ledger or Trezor, then you can still add your expert key in the wallet app and it will function as a watch only wallet. So we first ensure that the user is not is not trying to conduct a transaction from a watch only address, because we would have no way of signing that transaction. And obviously the UI will not let them select it. It's just a way of safeguarding the input that we receive on the backend side. So if it's a watch only address, then we simply bail out at this point in the handler here. And the second thing that we were doing is ensure the chosen account has enough funds for this transaction, return an error if that's not the case. Okay, so first of all, for that, we added a check. If this is an address, okay, since then we did change a few things, because earlier we were planning to, we are still planning to we have the ability to import paper wallets or singular addresses with their private key and public key into this vault here. But then the issue was, if we are maintaining an HD wallet and then singular addresses, which are still the accounts in the terminology of the wallet, then when conducting a transaction from them, where does the change of those transactions go? If they are completely spent and nothing is left behind, that's an easy case to handle. But if not, then that's a problem, because how exactly do we make it easy for the user to see where the balance of the funds of such accounts are saved now? So that way, the user story, the user flow that I considered was, the wallet app will create an HD wallet, and if you want to import such paper wallets or singular addresses, what it will do is it will create an import account in the accounts that you have already have, and then import that particular transaction in this import right away. So that way, there are no singular addresses to consider, and it's all a part of your HD wallet. So this will indeed require for a transaction to happen, as in if you're importing a paper wallet, the funds will be moved from that address on the paper wallet to an address under the imports account in this HD wallet that you have in this system, Vault plus wallet system. So in that case, we won't really all these singular addresses that will be in there will essentially be watch only addresses. So we can simply exclude all of this and simply get to this. So I'm gonna comment this for now. Comment this out. Leave a comment here. Since we won't be supporting individual or singular addresses as account in the vault, they will be imported into something like imports account under the HD wallet. Then hmm. Then in terms of spending outputs, which is sending my transaction outwards, we don't really, it's only the HD wallets that we are dealing with. So that's why all of this is skipped. And then in the case of this particular account is an XPub account, meaning an extended public key, which makes it a HD wallet. Then we'll have to make sure the chosen account has enough funds. So we'll start scanning the um, addresses under this and catch up to the point where we can start aggregating those addresses. Now that I'm thinking about this, if you will recall, we have this data structure. Actually, I'll do this. So we had this D index over here, which was for derivation index, as in if the user wants a fresh address to be generated for this particular account, then we use derivation index, D index here. But let's say uh, this is an extended pub key that they are either using personally or they are using in an external system like an e-commerce system, which keeps on generating addresses on their behalf and receive payments on whatever addresses that they can manage. So in order to, let's say if the e-commerce system has used like thousand of those addresses. So when it comes to sending out the transaction, it's very inefficient if we start scanning the entire uh, chain here, starting from the zeroth index for this account, because at certain point we can be sure that assuming that the addresses are not going to be reused, which someone accidentally can, we simply maintain another index, and that index simply indicates from what point do we need to scan for further balances ahead, because we know the earlier addresses before that index had seen outputs and they have all been spent, so it makes no sense to query their address, their balance, or whatsoever. In addition to that workflow, to be able to compensate for mistakes, for humanly mistakes, that somebody might send some fund to an address which is less than that index, which we will be using for our purposes for scanning for balance and everything, then we can have a function of let's maybe we'll call it sync or rescan, which will essentially trigger the scan from the zeroth index and scan it till the end, respecting the gap limits which is specified. So in that way, it will have the ability to correct that index. So at any point of time, we can follow using that. So we'll probably need to add another column here. For now, we can also skip it because we can simply start from the zeroth index and then later on add it. Or perhaps that is what I'll do for now. But that's something that I'll add to the GitHub repository, which I think I'll be able to set up today. Just making sure it's all up and running. Where are my chat windows? Okay. Let's see. We have the expert key here, and we want to generate the addresses. So we can need to use the code that we had above. And since we are trying to conduct a transaction at this point, we can also do, like, we just don't have the external chain to scan at this point. We also have to scan the internal chains to collect all those change and reuse that as well. So there can be a bunch of different ways to approach this, as in based on what logic do you aggregate those addresses. If there are multiple ways to go about it, do you just aggregate it all from the external chain, and if that's sufficient, then just simply use it? Or do you, as you're going deep into the uh, index range for scanning for newer and newer addresses, then are you keeping a tab on the internal chain at the same indexes as well? I think for the sake of simplicity, what we can do is, I mean, I don't know how other wallets do it, but uh, I don't imagine, I can't imagine that there will be an issue if I simply stick to scanning the external chain and only go scanning the internal chain if the balances in the external chain is not enough to sufficiently fund the transaction. So at this point, uh, generate address from xpub. We pass that xpub here. I will need to maintain the indexes here. Like this. I'm just got curious. Where were we using the index at 5 places? This one was at generating address. And how do I use it here? Simply put that into index here. Okay, since this, okay, makes sense. I should rename this to d-index to be consistent in naming. So this way, one look and I know that I'm dealing with the derivation index. And then perhaps I should use a little camel casing here. Don't use that in the SQL query. This is fine, this is fine, this is fine. Da, da, da. Don't use this in the SQL query here as well. T-index. Okay, that's okay. Then, where else do we have this T-index? Over here when, oh, okay. Let's quickly scan all the occurrences from the very first one. Okay, that's defined in the account data type. Then the index in the SQL query, which was the generate address handler. And here, the ones that we just modified. Oh, wow. Okay, this one is in the preparation transaction handler, which is fine. Got that in here. I can rename it here as well. I don't think I need to, because we're simply using the entire this big account variable which has the crypto account data type. And then what else? I think that's it. This was the last occurrence and this was the second last. Okay. Okay, coming back to what we were doing. Since we're starting from the very beginning here, let's go with this 0th index and we'll generate the address and we'll keep on generating that minding the gap limit. So it's essentially the same logic that we had here. Where did it go? This. Let's copy the entire thing and then see what changes will we have to make. That was something I only added temporarily. Okay, we were here. Okay, so we took a counter for the gap coverage, current gap coverage while iterating, then the index that we are using, and then the balance, which is needs to be greater than amount plus fees. Okay, we start with the 0th index, gap covered is less than or equal to gap limit, and keep on incrementing index, generating the addresses from the external chain here. Ensure that we got the address, debug information, then the get balance call for this address, balance and number of transactions. So we keep on scanning this way and we'll keep on accumulating balance here. So at this point we can check if balance is greater than amount plus fees, then we know that we have sufficient balance to conduct the transaction, and any of the change that's left here, the difference between balance minus the sum of amount plus fees, will go to the address which is at the same index here but in the internal chain. So but I think we won't be able to access index outside of this for loops since how scoping in Go language works. Let me quickly check that. Go language. Access last index of for loop outside. This seems to be something else. But I'm pretty sure that we can't access the index outside of it, so we'll have to generate that address here only. Okay. So now at this point, at least we know that we don't really have to continue with the loop. So let's specify the break. And what else? Oh, I mean, since index like I have defined the index outside, it should be accessible. Okay, okay. Only if it was a variable that was defined and initialized like this, then we won't be able to access that outside. But in this case, I think we're good. So now we have the balance, but at any point when we got the balance, which was non-zero, we did not aggregate the addresses. So we need to do that as well. And input transition input output. Still not ready to populate these variables. Input addresses, and this needs to be an array of string. And at this point, if balance is greater than 0, then only add it to the main balance and uh, append this address to input addresses. So now we're collecting the balance and the input addresses that are involved based on the transactions count that are there, irrespective of the balance. It mines the gap coverage and accordingly proceed. Then when we have it, at this point, we'll have all the input addresses. We have the balance to work with. We'll simply need to find the address at the same index, which is on the internal chain. Not change address. Ensure that we were able to obtain it. And then what else? We have all the addresses, we have the balance, we have the amount, we have the fees. Now we also have the change address. So at this point, we have everything. But again, I'll need this variable, the value of this variable outside. So I'll go ahead and define it here. Oh wow, it says declared and not used. So it's not able to access this, not able to pick up on this. Or is it just the linter? I doubt, because the linter is the comes with the core. So let's try compiling it once and it will let us know on its own. Yep, it's complaining about the recipient here and the inputs outputs here, all three expected, and then the change address here. This isn't expected. So how do we do this? I mean, we can do this outside of this because the index is going to hold its value. So no need to do it here. At this point, I can simply do it like this. Oh, did it not save? Oh, okay. At this point, I need to use it. So Just to suppress this for a second, I can just do this. Okay, cool. So at this point, we have all the information. The addresses to use, which are in this array, the change address and what the change is going to be. Oh, let's calculate that. We already have balance outside, so even we don't need to calculate that in here. We simply go outside, and change would be balance minus amount plus fees. So we have the recipient, we have the change address, we have the addresses that are going to fund this transaction, and keep on. Like, we can continue. We have all of the info at this point. We're only left with a case. What happens if we exhaust the limit of this loop and we still don't have enough funds? So at this point was external chain of accounts were sufficient to fund the transaction. So that will simply check if balance is less than amount plus fees. And if that is the case, we'll have to start scanning the internal chain now. And for the internal chain, we have to go as far as the index that we went to at this point. So we'll need internal index. That will be same uint32 and the same loop that we had here. Gonna go get some water. I'm back. Okay. Okay. We can also call it I, just as we did it here. And we'll leave a comment for ourselves. That's the internal chain index. And we simply start generating the addresses here. which will be the xpub key, the index, the I. Wow, why it's using the index I here? That would not be correct. This will be I here. Good thing that I got it just now. Oh, we don't even have the loop. That's why the continue wasn't making sense to the compiler. How about now? Okay, cool. Let's output the debug information here. And then same deal, balance for it. And since we are not looping as per the gap limit here, and simply based on how far we could have gotten on the external chains, so there's no way the internal chain index is running ahead of the external one. I mean, not if you're BIP44 compliant. So we don't need to care about the number of transactions at this address, just the balance, and whatever balance we have, if that balance is greater than 0, then we add it to the balance, just like that. And if at this point the balance is sufficient enough, then we can break the loop here. It's complaining that the ADDR is undefined, so it's not able to access this. How was it able to access it here? This was inside the for loop only. This will also be I. Going down below. So we're generating the address here, and okay, all of this needs to come inside of the loop. This does not make sense to be outside of the loop at all, because with each iteration we are dealing with a single address, and these are all of this code needs to run with each address when we obtain a balance of some kind. And we can also nest this inside of this, because it will only make sense to recheck this when the balance of this particular address was greater than 0. So this will break out when it has enough balance. At this point, we'll also include this address into the input addresses like we were doing here. And we break out of here. Okay, I think that makes sense. And the ultimate case would be if this is still inefficient, still not sufficient to fund the transaction, we notify that we are unable to fund this transaction. So the very first error that we had, would simply copy this. We'll need to indicate the error in some way. So perhaps we modify the generic variable that we're using right now. Success, let's add error, which will be of type error. I mean, the I need this to be string, but I'm just wondering if the error type can be used here in some way. I mean, it's simply because when at the receiving end it expects the error interface, then it can simply call this error method and it will convert into a string that it can simply consume. But in terms of JSON, don't know if that makes sense in that context. Whether while marshalling JSON, as in encoding into JSON, if we simply specify an error here, then will it simply call this method or not? Or we can simply, just be simple about it, keep it simple. We use string here and do it like this. And we'll come back to different instances where they are used and we can add error while we hit the need of it, as in when we'll be writing the code for the front end side, the wallet app, the Vue.js app here, and then we'll come back and make changes to the API. For now, let's simply jump to this point where we were. Yes. Ultimately, no funds under this account to fund transaction. So at here we can say insufficient funds, and I want to make these strings as constant strings that the Vue.js app can rely on. So perhaps while refactoring, I'll move all of the such error messages up at the top and define them as constants. Anyway, so if we do not have funds, which was the case that we needed to check here, ensure the chosen account has enough funds for this transaction, return an error if that's not the case. You can actually get rid of this entire thing. Ensure this isn't a watch only account. This was the check number 1 that we need to do here, and this was the check number 2 that we need to do here. And for that purpose, we did all of that. Let's cut these from here and move them to the bottom where they can still be used. Over here it makes sense. Now at this point we have all that we need. What's this to do left? If the chosen account is experb, start scanning the indexes for collecting the balance that can fund this transaction. We've already done that. Calculate that as for the change. So move that here. calculate the change and the address for the change. Done, done, done. At this point, we have to populate these. Okay, and I'm not sure about the data format that these two variables will have, so let's check out CoboWorld that I recently discovered, which is kind of what I'm trying to do here, except my own take on it. Mm, was it their blog? And like this, just want to mention this real quick. Being able to use a dice to generate your key, as in you are the one that's providing the entropy and not trusting the random number generator that's on the hardware, which is essentially a pseudo random generator. The CoboWorld claims that there is a true random number generator, but that like an actual true random number generator is not possible because the computer just cannot do it. So it gets very close. It's better than the pseudo random number generators that are out there. So at the end of the day, we simply want to rely on our random number generator to provide entropy, which is cryptographically secure. So instead of, since you're building a trustless system here, instead of relying on whatever is going on, there will be an option to generate your own entropy using dice rolls in this vault app. And apart from that, since we will also have a webcam connected, we can also just turn on the webcam feed, move the vault around so that it sees a lot of random stuff and converts the video feed into entropy and use that. Okay, is this what I want to look into? And it will be cool if the QR generated by these app and other apps and and my system is kind of compliant with each other. So if needed, one can swap out the vault, and as long as they have their seed phrase and they can restore their wallet into any hardware app, this vault simply becomes a piece of hardware that's easily replaceable, and you're just free to choose whatever wallet app hot or live, something that's connected to the internet. Whatever service you choose, you're up to that, and you don't have a vendor lock-in of any kind, and you can simply switch systems. Okay, yeah, this is it. Let's examine the unsigned transaction data output by the CoverVault app using a QoS. So only one QR. This is the 0th one, the only QR. Checksum for this value. They're also using compression, and this is the compressed value. If there's one, to view the unsigned transaction data in fully human readable JSON format, we need to decode the above value, but first decoding base64 and unzipping. So this is the unsigned data that they are passing. Oh, the revision parts. While I was collecting the addresses here, I forgot to collect the derivation paths, which will make it easier for the Vault app to know what derivation paths to use over here. So it can simply use their private keys to do the necessary signing of the transaction. Well, that's easily fixable. But let's see the data that's here. So data type sign, symbol, what the currency they're dealing with, sign ID, I don't know what that is. Derivation bar, time, display time, these don't really matter. Data, this is the recipient, the amount, the fee, and the inputs are, okay. So instead of passing the addresses, it's instead giving it the transaction ID itself, which makes sense because addresses are just an abstraction. And in order to sign a transaction, they will like, even if the address was provided to them, uh, the very first step the vault will simply do is find the transactions. Hmm. Since this is only a transaction ID and the vault app doesn't have a blockchain ledger to interact with, I can't say I see clearly how this is gonna work out. And that's because I do not understand how does the signing of the transaction actually works right now. And what's this? This is the vault output. Are they using sign ID to just be an identifier in this case? Mhm. Correct. Let's see what this data has. Oh, they didn't decode it. Okay. Or maybe they're simply using the transaction IDs here, no, not the addresses, because maybe that is how the Litecoin cryptocurrency works. I don't know. But in terms of Bitcoin, for now, I imagine that since we'll need the private keys of all these addresses that will be funding this transaction, the ones that we're collecting here, we would definitely need the address or at least the derivation path for them so that, I mean, yeah, not even the address, derivation path is more relevant so that it can simply generate the private key and public key at that index point, at that index in the derivation tree. And we are also specifying how much is the value that's gonna get out of each of those. Okay. Hmm. So I think instead of collecting input addresses, I can collect, or maybe I define a custom data type here. I'm not sure right now. I think this will make more sense once I understand the signing of the transaction itself. So let's start with that. Transactions behind the scenes. An actual transaction looks like very different from a transaction provided by a typical block explorer. Because in reality, these addresses, they don't exist. It's only locking and unlocking scripts that exist and the cryptographic puzzle that needs to be solved in order to be able to spend the outputs at a defined address, which is essentially the locking script. So basically, essentially, you unlock it when you have the private key for it. Hmm. So in this particular transaction, one is output and these two. What? Yeah, this is the input. Why does this say output here? Maybe it means something else. So we have one input and two outputs. So this is the input and V in, and output is these two. And as you can match the values here as well. So in our case, we will have multiple inputs and a single output. I mean, Bitcoin is capable, or any other cryptocurrencies for that matter, is can easily support multiple payment out addresses. It will simply be a matter of defining what amount goes to what address, and essentially there is no transaction which only goes to one address, because at the end of the day there will be a certain fees component that goes to the miner. So the fundamental building block of a Bitcoin transaction is a transaction output. Transaction outputs are individual chunks of currency recorded. It says almost all of these outputs with one exception. See this, creates spendable chunks. So what are these OP return ones that don't do anything? And obviously this doesn't work. So return. Oh, was it on the same page? What? It doesn't go anywhere. Wow. So for the outputs, we specify this kind of script, which will be the unlocking script. That makes sense. And they basically work on the in the LIFO format. So this gets pushed onto a stack, this gets pushed onto a stack, and things keeps on evaluating. And as long as somebody can provide the right inputs and the last result on top of the stack is true, then only then they will be able to unlock and spend this value here. The inputs point to the transaction ID this. as we can see here. Uh, okay. Whatever transaction happened in which this input was, the output is this one, transaction ID. And output index 0, the first UTXO created by the transaction. The unlocking script is constructed by Alice's wallet by first retrieving the reference UTXO. Retrieving the reference UTXO, examining its locking script, and then using it to build the necessary unlocking script to satisfy it. But since we have an air-gapped vault has no, which does not have the ability to talk to the blockchain itself, the vault app won't be able to retrieve anything. So we'll need to know what all it needs and then pass all of that info in one go. And then it can simply do, assuming what you have given me is correct, I'll do the signing like this. And if the information provided to the vault was correct to begin with, then the signed output of that will be valid as well and will be accepted by other peers and it will work out. But how? That I don't see just yet. Well, I'm clear on the concept of how the actual transaction works. But I understand that on a conceptual level, and as of now, I'm unable to translate that into code. So I'm looking for some sort of an example that will join some dots in my head, and I can do that. I can use that to do what I want to do here. Hmm. Let's look up Bitcoin signing transaction, Go language. Well, we also have a bunch of libraries, so maybe that already has some of the code. Transactions, RPC client. Create raw transaction returns a new transaction spending the provided inputs and sending to the provided address. If the inputs are either nil or an empty slice, it is interpreted as an empty slice. How is this able to function without knowing what the output is? Seems like it's all there, but it will require figuring all of this out. So I think I'll come back to it later on. Actually, let me try looking at an example if I can find one more time real quick. And if I can't, then I'll figure this out later on and then come back to it. And for now, we can proceed with things that we know, and we can finish those things. Go language, Bitcoin, sign transaction example. That's not this. No, they're building like a, where is a Bitcoin transaction? Okay, they're building a program that can connect to the peer nodes and without having the entire ledger with them. They're simply relying on what the peer is, for the whatever the information the peer is passing, the peers are passing them. So this requires, in a way, to have some trust on the peers, which is also eliminated if you run your own full code node. Okay, so for the transaction, it has an ID, V in, V out, which are transaction input, transaction output, and that's a value script public key. And transaction input is transaction ID, V out script sig, and it kind of works like this. It seems like this is the kind of stuff that I exactly need to know. So let's check out the tutorial from the very beginning. Make sure that we're not skipping on something that we'll need. Let's go to part 2. So they're still working on the communication between the nodes, which isn't relevant in our case, at least as of now. So we'll go to part 3 now. Okay. I also need to understand what a soft fork, how does a soft fork actually differs from the hard fork? Okay. It's only the part 4 that we need to read in detail. Okay. Let me take a sip of water and then we'll start. Transactions are the heart of Bitcoin. The only purpose is to store transactions in a secure, reliable way. But because it's quite a big topic, I'll split it into 2 parts. In this part, we'll implement the general mechanism of transaction. In the second part, we'll work through details. Oh no, don't tell me that there is no 5th part that was never published. God damn. Does it even make sense to read it now? We'll try it anyway. Um, Most likely, it says most likely we will create two tables: an account, information, balance, transaction. There are no accounts, no balances, no users. Since blockchain is a public and open database, we don't want to store sensitive information about wallet owners. Coins are not collected in accounts. Transaction do not transfer money from one address to another. There is no field or attribute that holds account balance. There are only transactions. But what's inside a transaction? It's a combination of inputs and outputs. So the transaction ID itself, V in, V out. What's the V here though? Never thought about that. Inputs of new transaction, reference, input, output, one. Okay, these are transactions. All of these can be clubbed as inputs eventually in another transaction, and outputs of these become kind of inputs of other transaction, and so on. Make sense? There are notice that there are outputs that are not linked to inputs, so they are simply unspent outputs. In one transaction, inputs can reference outputs from multiple transactions, and input must reference an output. Throughout this article, we'll use words like money, coin, spend, send, account, but there are no such concepts in Bitcoin. Transactions just lock values with a script which can be unlocked only by the one who locked them. Hmm. Okay, just a way of saying it. Transaction outputs. TX output, value. This would be the amount. Script public key. This would be the locking script. Or is it? Actually, it's outputs that store coins. Notice the value field above. And storing means locking them with a puzzle which is stored in the script pub key. Internally, Bitcoin using a scripting language called script that is used to define outputs locking and unlocking logic. The language is quite primitive. This is made intentionally to avoid possible hacks and misuses, but we won't discuss it in details. You can find a detailed explanation of it here. In Bitcoin, the value field stores the number of Satoshis, not the number of BTC. A Satoshi is 100 millionth of Bitcoin, the smallest unit that we know. And since we don't have an address implemented, we will avoid the whole scripting related logic for now. Script pub key will store an arbitrary string, user defined wallet address. Okay. By the way, having such scripting language means that Bitcoin can be used as smart contract platform as well. One important thing about outputs is that they are indivisible, which means that you cannot reference a part of its value. When an output is referenced in a new transaction, it's spent as a whole. Makes sense. And if its value is greater than required, a change is generated and sent back to the sender. This is similar to a real world situation where you pay $5 and get some change back. Transaction input is transaction ID. V out script sig. As mentioned earlier, an input references a previous output transaction ID, stores the ID of such transaction, and V out stores an index of an output in the transaction. Transaction stores the ID. V out stores an index of an output in the transaction. Okay. As in, like, this is the 0th output or the first output. Scriptsig is a script which provides data to be used in an output's script pub key. If the data is correct, the one that's provided here, right? The output can be unlocked and its value can be used to generate new outputs. If it's not correct, the output cannot be referenced in the input. This is the mechanism that guarantees that users cannot spend coins belonging to other people. Again, since we don't have addresses implemented yet, scriptsig will store just an arbitrary user-defined wallet address. We will implement public keys and signatures checking in the next article. Let's sum it up. Outputs of where coins are stored. Already knew this. What are they doing? What are they? The Coinbase transaction was seemed to be the one where the the bitcoins are actually generated. So let's see what they are saying here. And Bitcoin is the egg that came before the chicken. Uh, the inputs referencing outputs logic is the classical chicken or the egg situation. Inputs produce outputs and outputs make inputs possible. And in Bitcoin, outputs come before inputs. When a miner starts mining a block, it adds a Coinbase transaction to it. A Coinbase transaction is a special type of transaction which doesn't require previously existing outputs. It creates outputs, that is coins, out of nowhere. The egg without a chicken, this is the reward miners get for mining new blocks. As you know, there's the genesis block in the beginning of a blockchain. It's this block that generates the very first output in the blockchain. And no previous outputs are required since there are no previous transactions and no such outputs. Let's create a Coinbase transaction. What? So they essentially, I don't know, let's see. Simply specifies to whom it, which is who is the recipient. There is no input of this transaction and the data. This will be the locking script. If data is empty, reward to what? This is just a message. Makes no sense. Okay. TX input as empty here. TX output as subsidy to transaction. Nil input output set ID. Oh, yeah. I've heard about some messages being in Bitcoin earlier. So where's the field for it? Where does it say so? This is the very first transaction, yeah. So there were no inputs, only output. But still unspent. Okay. So this tutorial doesn't really have anything in terms of signing the transaction. Maybe this is it. Now we want to send some coins to someone else. For this, we need to create a new transactions, put it in a block and mine the block. So far, we implemented only the Coinbase transaction, which is a special type of transactions. Now we need a general transaction. Okay. So over here, it becomes from to amount and the reference to the blockchain. And it returns the transaction type. So input output, find spendable outputs from amount. Okay, not enough funds. Build a list of inputs, kind of what I was trying to do. Range of valid outputs, transaction ID outs. I can't make sense of this right now. So I'll just leave this tab open and come back to it later. So for now, let's continue with what we were doing. I wonder why Bitcoin.org is not resolving. Or is it just the developer subdomain? Yeah, just this subdomain. Whatever. Okay, I think Chrome just froze. Okay, it's responded. Anyway, where were we? Here. Prepare unsigned transaction here. And we'll simply return the JSON of that to the client, which will then handle the QR code generation of it. At this point, the code isn't compiling, but we'll have to comment out certain bits here so that we can continue working with it. Recipient, just gonna use that here. Okay, moving on. So these three handlers are done. These two are partially done. And need to have this query the balance director account. Yeah, that is scratch that. All of that is done. So now, if we come back to it, um, we have some basic code on the wallet app front end side. Let's quickly go to that. So this is the wallet app here. It's not currently talking to the API, the backend API that we just built. It's simply working off some hard-coded data. So that's something that we can work on right now. But first, let's go through it. This is the dashboard view where we show accounts and the balance. And okay, that doesn't work because the server isn't running. Or is it? Oh yeah, it is, it is. Is it? No. I think that works because of the static folder and everything gets redirected to the index.html. So why this won't work? None of these working. Okay. What's up, Nginx? I don't understand why this isn't working right now. I hope this is working and it's not cached or something. So Nginx is definitely responding to this request and even to these requests. So what happens with the essentially it's not able to rewrite all of the requests to the index.php. Oh, what? Why would it be index.php and not index.html? And if it was index.php all this time, how it was working till now? Okay, this loads. Okay, now it's functional. I don't know how it was functional with index.php being here, because we certainly don't have an index.php file at this path. Oh, strange world. Anyway, so this is the dashboard view. The add account option that we have. Receive crypto. Simply generates a addresses send crypto. Choose the account this and broadcast. Okay. Okay, so let's plug the API into this, and so that's something we can do. Plug the API into the, make sure this app here uses this API, not the hard-coded data anymore. Then the second bit we can work on is implementing this QR functionality that we have here, so that we have a JavaScript QR library, something that can encode a data that we pass it to a QR code, which we can show it to the webcam on the vault, which it will receive and do further. As of now, we have not written any code for the vault at all. So even the vault will have a Vue.js app that will run in an embedded browser, and it will have a small Go server that will be acting as a backend for it. I mean, as far as the vault goes, it can be totally inside a browser, but since my choice of tooling is using the Go server, it will use essentially the same front end and back end over here as well. So just iterating again, we have not written any code for the Vault app just yet. For the Vault app, if I am to list it down, let's do that right now, because that will also give me some more clarity. So Vault functionalities, which will be so as soon as you boot it up, the program runs. It will ask you to generate or import seed phrase. If you already have it, you import it. You should always be using a passphrase, as that's my opinion. It essentially gives you a second factor authentication layer on your seed phrase, and you can store those two things separately. Heck, you can even let your family members and everyone know about that seed phrase, but not the passphrase, which is something that you hold on to. Okay, so the very first step will be either generation or import seed phrase. For the generation, you can provide your own entropy, which is just inputting, manually rolling the dices and inputting those numbers in, or cam feed. And then in terms of import, instead of making user type in, like, I mean, at the end of the day, I should give both the options. Type it all in, type it all 24 words, or scan QR code for encrypted seed phrase. This is something that it will generate on its own after this step. So you can click a picture it on your phone, it's totally safe because encryption, because the seed phrase will be encrypted. So it will be safe as long as you're using a strong passphrase to encrypt it, which you will provide every single time you boot up the vault to decrypt it. So essentially, the vault never actually holds your fund when it's powered off. It's an ephemeral OS instance in a way. So once after this point, I think this will be better done here. Okay. Is this though exactly the one what we're trying to do? It's a little bit different. So essentially, the bootable media, not the USB, it verifies its integrity. So over here, generate wallet, yes or no. If yes, then it generates a mnemonic seed passphrase, receives your input. You either provide the entropy using the dice roll or the webcam feed, or it uses its own, generate it, and if it's valid, I'm not able to recall why at this point this won't be valid. Is it because the master index, the master private key, falls out of the range that's specified for the Bitcoin specification? Maybe. And if it's valid, then wallet initialize for the generation purposes. Where if there is no generation involved, you simply import it. And in terms of importing it, you simply provide the QR code here. Then you put in the decryption key, then it knows your seed phrase, and then at the very last you enter passphrase. So the encryption for these seed phrase for the QR code, so that it becomes easy for you to import it every single time you boot up the vault. It's different from the passphrase. You can choose to have both of the things same. That's totally up to you, but make sure in both of the cases it's a big passphrase and not just a dictionary word of 5-7 characters. Make it a make it totally random. Doesn't really even have to be a dictionary word. Like if you can remember random numbers, then that is it. Otherwise, use a big number, like bunch of 8-10 words, use as the passphrase or the encryption key. That will be quite secure. And the more randomness it has in it, as in like even the numbers are involved, small capital letters and small letters, those are involved, in some symbols as well. That makes it harder for someone to brute force through all the generations and figure out whether they can hit the jackpot or not, which most likely they won't. So we're good. Okay. So this is just the generation or import step, kind of. After this stage, the vault is booted up. It can either generate new accounts for you. It also, remember, it will have no memory of how many accounts you have generated previously. So if you are using the Vault app, that will assist you. And if not, then it's up to you to remember that you have generated the account for a certain coin at the 0th index and you are using it here or in some other system. And then when you want to create a new account, you remember the new index that you want to generate the account at. It's kind of inconvenient, but that's the cost that we'll have to bear with for now in terms of, I mean, or even the state can be saved in some way, like another QR code. We'll explore that later on. But for now, it's it has no way of saving that information because once this vault boots up and before this program runs, the bootable media is ejected. So in this case, the Raspberry Pi, which is going to be acting as the air-gapped vault here, It will have no SD card, no a hard disk, no SSD, nothing, no writable medium where it can possibly save anything, just to prevent your leakage of your sensitive information, which is the private keys here. So that's why it cannot save anything. So when you generate new accounts, you provide the index and it does the generation for you. It generates the extended pub key. It shows you a QR code for it, which you scan from your wallet app, and that's how it gets into there. And uh, you can give it a label. And that's why when conducting transactions, we'll be passing the derivation paths. So when the actual path of signing transaction comes, it will know at what paths exactly all those addresses reside, which are involved in the transaction that the vault is supposed to sign right now. Generate. And apart from generate, the only work it can do is sign transaction. So not a lot of code here. I mean, at the very first run, when you try to set it up, you generate the code, you save it all in safely. And then when you're generating new accounts, I suggest you simply generate multiple accounts for each currency you think you're going to be dealing with and import, like add all of them in the wallet in one single go. And then you simply won't have to boot up the Vault app until it comes to the point where you have to send funds to somebody. So if you're a hodler, then you might not as well be switching this Vault on for months. And it will work even after you boot up after months. And there is no issue of any firmware upgrades or whatever. So for maximum security, what you can do is uh, that SD card that you have in there, you can like simply discard it and take another fresh SD card, write another OS, the image for the OS that I'll be providing, download it, write, burn it to the, I'm not sure burn is the right verb here, but write all the files to the SD card, then use that SD card to boot it up. And then since it has no memory of the previous OS installs or instances, it will simply boot up using whatever you provide that in the SD card and run the program. So there is no way of any issues like in the other cold hardware wallets where a firmware upgrade can mess up the wallet structure, and if you don't have your seed phrase backed up, you are in a big trouble. You might get locked out of your funds completely, which is totally opposite of the purpose of why hardware wallets were created in the first place. So okay, in terms of backend work involved, the front end work involved, this this is not a lot. I mean, I have to figure out some stuff here to understand how the webcam feed is converted to entropy, how the dice rolls are actually used to provide the needed entropy and use that for generation. I'm aware of how to generate the addresses and everything using the using the entropy, generate the seed phrase, then the mnemonics and everything, the addresses, aware of all that. Just have to learn the signing transaction, which I'll do when I'm learning through the signing transaction aspect that we were just reading upon. So both of those things will be knocked down in one go. Okay, much clarity. Cool. And what's the day today? It's Thursday. So, hmm, um, if you're following me on Twitter, I tweeted this today that I have received the parts for my Raspberry Pi. I got the Raspberry Pi a few days back, so I have all the hardware that I need to build this Vault app, and I plan to work on the custom Linux OS for it and all the soldering stuff, the headers and everything sorted that on the Raspberry Pi board. I'll be doing that on over the weekend. So 27th and 28th, the weekend is for figuring out the running environment for the Vault app, and a sample program can run over there. Both of the days will go over there. So it totally comes down to how much work we can get done today in terms of uh, everything else today and tomorrow. And if that's enough work, then at least if everything goes all right, then at least we can get to a point where the Vault app can generate. I mean, I might be underestimate the issues and the roadblocks that will come in terms of implementing this. But if everything goes, the plan will soon be able to generate the accounts and everything in the vault, add them to the wallet app, and see the prototype functional without using this Bitcoin Core node, of course. But once that's done, then we can simply keep on building it further and further. That's the idea. Also, if you don't really want to eject the SD card every single time you boot up, then the software is not gonna write on it intentionally. But be sure that if your Raspberry Pi gets stolen or something, the SD card might have some sensitive information onto it. I mean, I'm doing as much as I can to prevent the software from writing anything to it, because once the OS loads, it's not gonna use the SD card at all. It will totally load completely into the RAM. And actually, what we can do is once it boots up, I mean, like this is only for the cases where you don't want to reuse the SD card, where you want to use the reuse the SD cards again and again, and not just use fresh ones. Whenever a new update is released for the Vault operating system, which will be once in a few months, kind of a scheduled thing. So if you want to reuse it, you can, but make sure that in that case you are ejecting it after every single boot and not just leaving it in there. Just as an added precaution that you can take, but the software is not intentionally gonna write anything anyway. It will try to run totally off the memory. Okay, let's come to it and start building the backend API for it. I'll go get water and we'll get started. Okay, I'm back. Let's get started. Quickly check the chat here. No comments. Okay. Okay, let's see. Okay, so we're loading the mock API.json here. Let's open this and then let's try to have the same data from the backend server. And okay, then for the localhost 3000 load, let's see what data do we get. symbol ID label address is xpub balance. So the balance is in Satoshis now, and some extra flags. And so backend API, I've specified the port, right? Okay, yes. And it simply becomes load. Get all of these out. And that should load. Let's see. Huh? Don't use cache, okay? Okay, it's fetching here. And the request failed. Why did it fail? Oh, why am I not able to scroll it? It says failed. It didn't say the server responded in some other way. Did the timeout happen? Was it timeout for the Axios? The default timeout is set to 0, which indicates no timeout. That is a very stupid default value. Let's give it 10 seconds. Reload. Oh, it failed again. So I think it's like the front end that's canceling the request. Now, why would it do that? Oh, oh, because the URL was, it did figure out the URL correctly, but I says backend API here, not backend. Oh, it's both incorrect at the both sides. Backend API. Let's go with small. Why is this not working? Why it would cancel this request? This is actually exactly the request that loads here, and it's even firing up correctly because the backend starts the, it hits the load handler, it fetches the balance from the API. Hmm. What is happening here? This loads here just fine, but over here it cancels. What does the status say exactly? Cancelled. Now, why was it cancelled is what I need to know. UJ's exhaust request cancelled. Gets cancelled on its own. Does the mounted function have some sort? Is it because that this is an async function and this gets terminated quickly enough so that it's not even listening to the response request? I think something of that sort is happening here. So let's find an example. Mounted exhaust get, then it doesn't say anything of that sort. Perhaps I can try using catch here and see if that gives me anything. Hmm. It's still cancelled. Let's make a change in the backend. In the load handler, instead of fetching all this, how about if I just return the request right here without anything? Does it still say cancelled or something else? It says failed this time. Okay, how about I just read the mock API JSON file in there and just write all the file contents over there. Go language, read file. Simply do this. So if you want to read the entire file, you can read it like this. And if you want to control how you read that file, in case of big files, you can do it like this. But for our purposes, we'll do it this. What does a check function do? It simply checks for error. And how do we provide the path for it? This is the full path. Read this file and write this file. I mean, write the contents. Write JSON. Can we use that write JSON abstraction here? Because it expects the object in that sense. And then JSON marshal it. We don't want to marshal it. We simply want to do this. So let's do this. I just hope it compiles without requiring me to make more changes. Cool, cool, cool. This didn't matter after all. Let's see. So now this should simply return. Okay, this is simply returning the JSON file content. Let's see what happens here. It's still failing. Wow. Why though? Okay, so could it be something related to course? It's able to read the content length of the response here, or just the headers. Failed to load response data. This doesn't make a lot of sense. It failed. Let's look this up. Let's try disabling the ad lock. Pause on all sites. Nope, still failing, but in the same error, except it doesn't say here this time. Or it does, I mean, click on it. Must be related to course. Yes, that's a good idea. Let's copy this as a curl in the bash and then try to run it here. Whoa, easy there, but easy. What did I just copy? What just happened? Let's copy this again and paste it in a text file first. Why is it copying every single request? Chrome, are you stupid? I'm just asking you to copy one single request. So I just need this one. This should fail as well. Let's see. Let's clear this. Nope. It was able to fetch it just fine. I'm not using any cache manifest file or whatsoever. I ran into this error on my localhost on a Monday morning when requesting one of my virtual hosts. Turned out I still had an unfinished debugging action running on another virtual host, which blocked Apache from serving the files for the other request. Not relevant to me because I can open it up in the browser directly and it loads for me. There you go. This guy has its server in Kubernetes. When client uses ingress route to serve problem API, so what is going on? So when this actual request works in that context, it simply doesn't work in the context of the browser. How about I try this? This in this browser and see if the same thing is happening here. Yep, same thing here. Oh, Japan using the copy all. Should I use this only? Must be for the Windows. Yep, what a joke. Hmm. I think this has something to do with this request being fired in the mounted context. And if I were to move this out, let's check. Did we get anything in the console though? I think I'll check that. Should have just taken a look at the console. From origin, at this from origin has been blocked by CORS policy. So I simply need to enable CORS headers. I mean, at the end of the day, in the production, both the both the URLs, the from where this app loads, which is this URL, and the backend API, which is this, will be on the subdomains of the same domain. So don't recall whether cost will be an issue in that case, but since over here it's different domains, that's why it's an issue. Perhaps if I can just route Nginx, yeah, I mean, like I can either add the headers on the Go language side, but unless I know that I need to do that on the production end side, I don't want to add code to my program. I'll simply prefer to keep it outside of it. So what I can do is go to Nginx, go here, configure API, which will proxy request to what is it? Localhost 1000 port. Oops. Sudo nginx. Oh, the test failed. Hang on. Line 21. Hmm. That works, but I'm pretty sure I won't be able to edit it. Yep. So is that not how you specify proxy pass? Was there a string? Invalid URL prefix. Invalid URL prefix. Would you be happy if I specify it like this? Oh yeah. Okay. Let's see if on the same URL, I can use it like this. Looks like it's working, except it didn't pass the URL, I think. So that's why it's treating everything as if it's hitting the absolute root, this URL. For which we would be seeing hello in our case here. Oh no, we are actually hitting the request. What? This isn't hello. And if I do it like this, it loads the wallet. And if I do it like this, mm, just the API, nothing else. Think I configured my API wrong. Yeah, because in this case, when the slash API URL should appear to the backend application as just a slash. So that is why it's not working. I'm not sure if this would work, but nope, it's doing the same thing. Essentially want to strip the API prefix in the URL. Let's try this rewrite rule. If this doesn't work, then I'll simply go ahead and add the cars header, because this isn't really worth wasting this much time over it. So we are rewriting essentially everything to just this. And obviously that's not the right syntax. So how is that supposed to look like? Will it work without this? Nope, 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 nope. It's essentially working in this way. And even that's not working. The trailing slash here. Was this that we were missing? Nope. I hope I don't have to deal with the pre-flight requests here. But let's see. This is handling at load, so okay. Seems to be working now. That was pretty easy. Anyway, moving on. Let's remove this and let it fetch the actual call. It got cancelled again. What the hell? Error time. Oh, the timeout is in millisecond. That's my bad. So it's fetching. It showed up. That's good. Let's remove this temporary limit that I had earlier. And just quickly test it's all rendering correctly. As per this, personal donations, e-commerce, and the call. Let's see. It should work just fine. Mhm. Did it hit the timeout? What happened? Is timeout exceeded? We won't ever need to increase this timeout to this big when we would be using our own full node. Also, I mean, it makes no sense that I optimize this at this point by using Go routines. Like this function, building this, rewriting this function to work as a Go routine, send all the requests in one go, collect the data much faster, and return that. Something went wrong with the API, I can tell. Okay. Do we actually have no? Mm, anyway, whatever it is, what's this function is indeed working. I can plug the limitation here so that it doesn't take that much time every single time it loads. Okay, what else? We have the dashboard. This edit function is not supposed to do anything. So let's hide that for now. There's also this weird thing. I enabled this extension and I think I'm supposed to get another tab here, but I never do. Oh, I didn't restart my server, so it's fetching everything again. Okay, that's a cute little dashboard that we have here. Going to the account add screen. Why did it try to fetch the balance just now? What's this that's going on? Oh, okay. So that happened because right now it was simple hyperlink and the single page application actually loaded again. So the mounted hook fired again and this load call went out again, and that's why I saw this output. So we'll need to change that as well. Okay. The actual add account call when we click the add account button. If I add account, this function which does a post request to the add account endpoint. And is this the same endpoint? Add account, yes. Label address is what we receive. Label address xpub, which will be empty in this case. Symbol, which will be BTC in this case. And then whether it's a watch only. Okay, so symbol and watch only is what else I have to pass on for the purpose of only supporting BTC as of now. I'll just hardcode this, and watch only will matter if I simply putting this in manually or hitting the scan QR code and then doing it. So for that I need a variable from add account label from add account address. So this becomes from add account watch only. I'll assume it's false, and if the I'll assume it's true, and if the QR code is actually used, then I'll simply make that as false. And actually this would be a good place to hard code symbol as well instead of the form over there. Label address symbol, watch only. So label address I mean, I'm expecting the address and expert to be doing two different fields, so I'll have to pass these into two different fields. Okay, so now we're passing all the data. We just don't have anything tied up to this, like the no extra field that's tied up to that. So over here, let's change it and add another field. This will be just a Bitcoin address. Do, 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 do. I don't like how new code editors and everything don't give a, don't care about closing the self closing tags. Don't want it hitting the request API every single time. So for now, what I'll do is okay, cool. So now I have the label, the address, or the expert key, or I can scan the QR code, which will also be an expert key from the vault. This looks better. And in this case, I should indicate that this will be watch only. So now it's clear that if a user adds the address of the extended pub key manually, they are adding it as a watch only address, and if they are scanning the QR code by the vault, then it will have sort of full access. Now needs to tie up the right model to it. Bitcoin X pub. I think if I can wrap this up. Because what happens when you click on this? It will fill in these models only. This one to be precise. So this thing entire gets hidden if it's based on the value of watch only. So this gets hidden. So let's wrap this. And what's the value for this? Form, add account. Wow, why it's not suggesting this one? If it's watch only then show it like this, which by default I assume it to be true. And over here for this, assume the same thing. Okay, so fail to resolve directive ID. 17. What? Okay. Okay, that error is gone. Failed to resolve directive ID. Okay, so it has something to do with the ifs that I'm using. Does that help? Nope, wasn't related to that. So it says ID. I didn't write any variable by that name. Oh, did I mistyped if to be id? ID. Oh, yep. That's gone now. Okay. So let's try turning format account address. Account watch only. This is true. Let's toggle this. So that gets hidden and the extended pub key will be populated. Okay, so we need another variable here, which will be format account QR scanned, which will be false to begin with, and form account. It takes a little while to catch up on the if it has been scanned, then it will also say again. So for when the page loads, it looks like this. And when the QR code is scanned once, we we flip the watch only flag so that we know that the QR code has been scanned now. So it's not a watch only address. So it will looks into this, and whatever we scan is showing up here. And apart from that, we also don't want this or showing once it's scanned. So let's wrap this as well. I mean, in the end, it will simply be, it won't be BR, so let's just replace it with span. Now we need a block element here. So for now, I'll just switch to div, and 10 is a little too much. 8 looks all right for now. And by 8, same goes for this. Okay, let's go through that again. The user loads, it has 3 options. Either add the direct address, which will be watch only, direct export key, which will be watch only, scan the QR code by the vault. If they fill in this directly, they can submit this and will be on our way. If they scan the QR code, then the watch only address, watch only flag will be flipped, which will result into this. And whatever we scan will be showing up in here. And add.format account address, QR code scanned. This will also be flipped. So even that gets hidden. And we're simply displaying the button here with the again key now. So earlier it was not again. But when this happens and this happens, it says again. Cool. Okay, this happens. Then we can either scan it again, which will set the same values that it said earlier. So nothing is going to happen in terms of flipping the fields. And we simply pass on the label and the extended pub key to the backend. Time to test the form with actual input. Let's do that. Let's say view1, and let's just reuse these addresses here. I just wanted to pop that up so that the webcam window is not hiding the input here. I can simply do it like this. So view1, this address, which will be watch only. I click on add account and it says cars policy. So let's go and add that. Cars line has been added to all the handlers. Restarting. Hmm. Okay, reloading this. Testing with view1. That is label, address here, and add account. And it says blocked by cars policy. What? Okay. Mm, let's see pre-flight options gone. Should work this time. Even as the label, did the placeholder go for this one? Uh, it's right here. Maybe it should have a placeholder. Okay, it does. Added it. Add account. Went through. What is this? Console.log output, I think. Let's take a look at the database. A bunch of empty accounts have been added that I can see. It will be easier if I just use the GUI here. Let's close this. Shouldn't be a problem. Okay. The backend side of things. Why did it? I guess I'm not checking if what I got is empty or what. If label is equal to empty, or if either this is empty or one of these is empty. It will be if either this is true, this is true. So we want the opposite of that. The board should be if both of these are empty, which will be empty if the input is empty. Then we have to return the error. But if one of them is specified, then this will be false. And at least one of them is specified. I think this is it. Cannot convert double quote type and type string to type int go. Which one? But what? I don't understand. Oh, yeah. Hmm. Okay. If all of this is empty, then we return an error, which will look like this needs to be defined on the top. Bad input. We can also return 400 at this point. Let's actually do that. Golang. This is what I need. Use the right JSON here. Yeah. The So this puts out the JSON and this puts out the error code, except we just need to find the right code here, specified output here. Okay, this should be good. Restart the server. Okay, we're here. Now, at this point, we have nothing added. Let's click on add account. To the white field, just let's reload and then see. Response. Okay, so since still having prefer light cores issues. Empty lines have been added. What? How did that happen? If even label was empty, this was false. And if this was empty, so actual request goes through. It's just a pre-flight. Okay. So let's ignore that call server for now because only the pre-flight request gets errored out, but the actual request goes through. So, where did we get the empty rows here? That is the question. Click on it, network, which is the very last one. Wow, is it scrolling or is it just appearing to us doing something? I don't know. Clear, add account, failed. This was 400. So it indeed result. Okay, I think we're not returning here. That is why this is happening. This is empty. Reload. Clear. View 1. This address our account. Error. Look, still got edit here. What the hell? Mm, let's see if the pre-flight edit is gone now. It's indeed gone. That's good. Now it says bad input. And based on the data that we passed, we gave everything. We gave 4 of the things except the expert key, which is expected. It should not have got caught in this section, so that means this condition is wrong. If label is not empty, this will be false. So now it depends on this. Either both of them needs to be empty, which is not the case here. So this will be true, and it will be if I do this and one of them is specified, makes no sense. If both of them are empty, then it's a bad input. So why isn't this working? Let's check the logs here. Restarting server. Hitting it again. It says false. That was my clue that I didn't pay attention to earlier. Why does it say false? So basically it's not able to get any value. Why is that? Oh, it was passed as a JSON, not as parameters in the body. So Axios post. There should be a parameter for this. Your data, which is essentially this. Will this do it? Let's see. Still says bad request. How to post query parameters with Axios. Okay, let's try this. Mm, so it says instead of passing the data like this, we specify null here, and then in the third parameter we specify it like this, and that is supposed to, how is that supposed to have the name for the fields? Let's give it a try. I'm not sure. Maybe it will work. Let's try it. Where are we? Reload it. V1, paste. Nothing here. Nothing here. That account. Oh, okay. Now it need not post the value of the parameters in the URL itself, though it went through correctly how it should have. But I'm not okay with it showing, like, essentially it didn't make a post request. Maybe internally it did, but the parameters didn't pass as post parameters. They pass as get parameters, which is not what I want. Calling parse parameters. Keeping a copy of it here, and then reverting back to what we had earlier. I don't remember what we had. Let's check in the Git real quick. Okay, is this it? Now below it. Okay. I earlier had these values passing in the second parameter. So there was no params key here. like this. Okay, so no modifications. That means it's exactly how it was earlier. Running the server. Add account header. Okay, and I'm gonna take a 5 minutes break. I'll be back. Okay, I'm back. Okay, so we were trying to figure out the post parameters that we're passing here. Let's see, the light is still good. It's okay. Hmm. Okay, so the post request can have the data in the key and values are encoded in key value tuples, which is essentially like the none of the data in the post request goes in the URL like get request. So it's either form URL encoded. This is when you submit a form. Multi-part form data, which is used when you have like an image in your form. And then the text plain. Not sure what this is. So this is how it should go. But instead, what's happening is it sends the entire data in a single JSON. Copy SQL, so it looks like this. Where's the payload over here? So it's sending all of the data is binary. Post data binary. I mean, how does the curl send it when I do it like this? Curl X. Oh, hold on a second. Localhost 3000 and is equal to 1. Okay, this is how it's passed. And if I specify here as label is equal to curly, because we already have curl in there, and then address is equal to, it doesn't go through because did that even cause and effect. It didn't. It's the curl itself which is stopping me from doing so, I believe. Was X not the shortcut for the post request? Could not resolve host. Okay, and then what? Okay, that needs to actually go to the address. So it's going there, but nothing is happening. Hmm. Curl. Different ways of sending data in post request. Yeah, so when the form submission happens, it uses form URL imported content type. In our case, it is sending data in a binary format, as we could see here, and then it's an entirely a JSON object. But is this a proper way to send the post request? Is data binary? So it sends everything as binary and then specify the content type is application JSON. Okay, go language. Parse JSON body. Form post. Okay, this is exactly what we are going through. So it says just decode it. You need to read from request.body. Pass form method is reading from the request.body and then passing it into standard HTTP encoded format. What you want is to read the body and pass it in JSON format. Okay, something like this, string body in JSON and Marshall. This looks like what will work for us. I was driving myself crazy with this exact problem. My JSON Marshall and Marshall were not populating my Ghost truck. Then I found the solution at this. As with all structs in Go, it's important to remember that only fields with a capital first letter are visible to external programs like the JSON Marshaller. This isn't what we were after. Okay, so this was relevant to us, so let's try doing this. So dot body string body, then unmarshal it. So now I have to create the structure for holding this. Where did my mouse go? What do we call it? Our account submission. Account submission. Let's call it S. It's here. Restart the server. And let's try issuing that request again. Same error, but this time we were able to parse it. Okay. So what happens if I send the post request like this? It doesn't do shit. Call post example. And if you do it like this, it will work exactly. What? That didn't work? Why? That should have worked. That is essentially what's happening here. Nothing seems to be happening. So this didn't work. And this didn't work. So will this work? I mean, these cannot work. I mean, these are not even being caught up by the form value methods. These. What's happening? These are not sending options request that it will return it. Give me a second. Oh, it's taking a lot of time to save. Okay, where were we? This doesn't seem to be triggering it at all. So fine, sending a JSON body, but what doesn't make sense to me is if I want to just send that post request as a curl over here, why doesn't that work? Maybe I can just copy over the curl that was actually sent for that request from the browser and then see what the difference is. Where's my app? Okay. A request, it failed. Why did it fail this time? Oh, because we reverted it back. Okay. Wait a second. Kind of lost here. This worked, but in by using what method? And this is supposed to work. What was the output for a server here? Yeah, so it is working like this, passing JSON body, which is where? Here. Okay, like this. So this works as it is, but over here it doesn't say that it works. Oh, okay. So this failed, but the request worked. Obviously, we didn't create anything because it didn't get to that point. Okay, let's see how we were sending the request in this one. Okay, kind of looks exactly the same like above. Is it exactly the same if I delete this line? Is it? It might be. It is. Okay. So what happens if I send a request like this? It will obviously work. I mean, work as in that I'll see the outputs being picked up like this. Correct. So I simply have to pass the data as binary. And interesting bit is that it does it even say that it's a post request anywhere here? What does it say? Connect to this host, use this header, this header, this header, this header, user agent header, header, header. I mean, all of these are headers. And then it says take this binary and compress it. So it's not a post request, except here it says it's a post request. Um, it's not a standard post request. I think if we send this request as a get, it will fetch us the same thing. So this issue has bummed me out because it's not even an issue. It just doesn't fit in your mental model of how something should work. So what should I do here? Let's do this. I switched this to get, right? I refresh this. Let's say v7, da 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 da. Add account, same. Whoa, unexpected end of JSON input. How the fuck did that happen? It is getting a response now. This time, no data was passed. Whatever. I think something is going on that I clearly don't understand. And I think it's just a post request, except the data is being passed as binary. So it doesn't care to show it anywhere else. With a get request, it doesn't make sense to pass any binary data at all. If any of the parameters that are required to be sent, they will be sent in the query parameters in the URL itself. So with that in mind, let's change our code here so that we are using these values everywhere. And considering so does that mean if I do this, then I kind of get all the outputs. I will receive all the outputs. Mm, s dot label, s dot address, s dot xpub, okay, it's continuing changing these fields here. Mm, where were we? What else? What else? 288. That's here. Oh, it should compile now. And if we send this request again, oops, error happened again. No, why does it say unexpected end of JSON input? This is nuts. Seems to me that it's not able to pass any data at all. It's exactly this. Where is the data? Where is what's what is oh, damn it. It will work this time. Let's work with a proper example here. We'll use v2. Close all of this. v2. Add account. The request went through. Here it is. Okay, and if this went through, would this go through? Nope. Let's see how to pass. Where is the app? Copy the request here. I copied the wrong request. Copy this one. So overhead has the data binary option. Oh, data binary switch is what I'm missing over there. So if I make it data binary v3 da 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 da, enter, still didn't go through. What the hell? Because at this point I want to match this with that. So call request to, oh, it's add account, and I've been sending it to add address. So what about the earlier formats? Will any of this work? Most likely not. It did? Jesus. So I have the endpoint here wrong, and that's why the call requests were not working. Because even now, if you look at it, I didn't send any binary data. I simply sent a JSON request. It worked. Wanna try simple this kind of an address and see if that will do anything. Nope, that didn't work because it expects JSON in there and it's not JSON. So okay, I can live with that. Let's delete all the stupid stuff that we added and make another request. Add account, add it, sweet. It's only a watch only address. And if this is xpub here, version 3, add account, that will go through as well. And if I flip this switch and some this is added here, before add account, what happens here? Before expect watch key 0 as intended, perfect. What was the other flag? QR code scanned. So that was purely for changing the state of this button and nothing else. So I think this add account functionality is done. And completely reloading it. Now let's quickly check for the validations one more time. If I pass on an empty request, what is this empty line in my logging? This was empty. All right, makes sense. Don't need this now here. I actually like how, since JSON is able to transport the data type of the variables as well, I like how I don't really have to parse this into a bool or anything, and it just works. So long. Da 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 da. This stays with the to-do. Fetch all addresses along with balance. What is this? Add account handler. This is just a comment from the earlier TV connection. Insert. Why would this return an error if this is already? I think this is redundant. But yeah, whatever. Let's not get into that right now. So at this point, it gets done. Okay, so now our accounts are also tied up to the API. Coming to receive crypto. What do we have here? Get fresh address is the call that is in use here, I think. Generate address. Yep. So we don't have any option added here. Why is that? Form receive payment account and Bitcoin accounts. If only if xpub is true. So what? Should have one address at least here. On the model, oh, the model isn't initialized here correctly because I have that limit over here, not here. Somewhere, the load handler. So that's allowed till 3. I know that it will make a bunch of calls, so maybe you can short the. I mean, at least let's load this for the purpose of. See. Wow, it's not doing anything. What's happening? Did this not fire load request? It fired it now, and here we go. So once that is done, we should be able to see who won and trade, then drop down there. Commerce, sweet. And what else? Didn't mean to do that. Go back. Okay. Oh shit, I shouldn't have clicked. It's gonna fetch all of it again. I should maybe change this first. Once that happens, this. And in the get fresh address, we log the form receive payment account, which is the value of this. So essentially, this simply passes on the account ID that I want a fresh address for this account ID. And that is it. So what's the value inside this model here? 3, right? The account ID itself. And over here, I don't want to use a simple get request because that will generate an address which maybe I can. Generate address. Count is equal to this. Let's get some. Okay. let's see what happens when we hit it. So I need to reload it again. I need to restart the server actually. What? I just cancelled the server, start it again. And it again started generating the request. I don't know what happened. But never mind. Let's go here, reload this. So it was able to generate the address for it. This will be a 500 error in our case because it's an internal server error. The user could not have provided anything else to make this go through. We just simply don't have the expert in existence, which is not gonna happen, but just in case, we'll have it there. So lots of error that can happen here. I'm not sure at this point we can either retry again or we'll have to continue with that new index, but gonna leave it here as it is for now. Simply don't return an error and simply this, and when it comes back to me, then I'll look into it. So at this point, there was no error, so we have the address, so we update the index, and And what is this? Oh, checking whether this query executed or not. And over here we simply return the response which has success and the address over here. Cool. So this should be all set here. Let's test it one more time. Server's up and running. Reload this. It's running the load handler, fetching all the balances and everything right now. And oh, whoa. What is this? Why does it do it twice? Do I have two export accounts? Just run. Oh, I think that was the internal chain as well. Let me quickly verify that. Load handler. It's a regular address. Fetch it. If it's an HD wallet, fetch all the external, fetch all the internal. Okay, makes sense. Now once it's loaded, then this and move this one here. Select the account, click on generate address, it gives us the address. And we can see the index is increased too. If we keep on hitting, we're getting new addresses, and if we refresh, the index is increased. Sweet, that works out as intended. Oh, I like this song. So we're done with the home. The dashboard look is done. The add account works. The receive works. Then before we do the send, let's do the broadcast. But how can we do the broadcast, because we have not dealt with the QR generation code as of now. So I guess we'll get to the send crypto one. Over here it's again running the load for the purpose of this, so that it loads up fast. We limit it to 2 so that it doesn't hit the expiry, and it loads fast. That's all. So send payment. When we're in this page, it knows what's the balance of all the accounts are, right? I mean, it would be cool if a user can select an account even though it does not have any funds. So in a way, since it doesn't have any funds, it kinds of holds a transaction and doesn't broadcast it unless it detects the funds are there. So it essentially gives us the ability to schedule out transactions. But then that kind of goes against all the checks that we built today, whether we check for funds and see if we have sufficient funds for sending out this particular payment or not. So at this point, I think it's a nice to have. I mean, at that point, we can simply okay. Let's see. Follow me here. Send. Prepare send transaction handler, right? Over here we check. We have all of these fields that I need to add now, and we check whether we check whether the chosen account is enough funds. So at this window where we are specifying information when we'll submit, this is the handler that will get executed. So even at this screen, we can inform the user whether they have the funds or not when they're trying to input this in here. Because like when they select this account, we show the balance here. Select this account, we show the balance here, and then warn them, like have two buttons here: send payment or schedule payment, and if it's just a send payment, then limit them that they cannot send this transaction out because they don't have funds. And if it's a matter of just scheduling it, whether they have the funds or not, then they simply schedule it, do the entire process like they can do, and accordingly have a condition: push as soon as funds are received, or when we know that there are funds, we let them choose a particular schedule. Cool use case, yeah, no doubt about it. For now though, what do we expect from here? Account ID, which will be this. Recipient, we don't have the recipient field in here. Who are we sending money to, bro? Let's figure this out. Let's see where this field is. Send payment. Let's search for the button here. This is the input. Let's duplicate it. Call it recipient. From send payment recipient. And this will be an address. Where's the label though? Okay, let's move it here. Copy the label as well. Oops. Labels are all wrong here. Add account lib. Send payment amount. Send payment. What is this recipient? Need to define those two variables. We have it here from send payment account and amount, and then we'll need one for recipient. Okay. Models are correctly binded now. Reload. No errors. Okay. This will load up in a sec. Load up, boy. What? Come on. Okay, all the three models are binded correctly. What now? What does the backend expect? Let's take a look at that. Account ID. Recipient, amount, and then fees. Let's change the code to handle it, since we'll be sending the request in a JSON again. So JSON, come to daddy. So we'll be doing this. So probably need a new data type here. Oh. Oh. First, this needs to go to the backend server first, and then what it runs, based on that, the QR code can be generated, which will be shown to the vault. So I think so better name for this would be prepare send trans. What's my endpoint? Prepare send transaction. Prepare send. Yeah, but this should not have the this label as send. It should be prepare transaction. So upon click, it fires this function, which is this, and at this point, just like this, to send transaction, because that is what endpoint. Oh, damn it, define this handler.
Yo, this a war zone, homie. Say you ready and prepared. Take a minute, make them aware. Well, I'll be sneaking in the back, but it's what the clap. Homie, life ain't fair. Caught me crawling through the mud with a vision, saw it clearly. Born a shepherd to these sheep, make them fear me. This a war zone, trenched out, trap house, nothing ever given. Yeah, every day's a blessing. Thank the Lord, oh how I'm living. See me riding with my top down. Oh, cops round, pedal pressing on the gas. I don't think I'll ever stop.
App.js, checking the variables 169. We'll get back to you. Forms and payment, right.
Binary choices and voicing our equally shallow opinions more loudly or quietly. Most people can't even decide what color to wear or which burger to eat. But does it matter, man? Autonomy is an illusion.
System. one. Okay, this is one of those. Then account becomes funds and payment account.
Autonomy is an illusion.
Autonomy is an illusion. So true.
Autonomy is an illusion.
Recipient form send recipient models working connected. Let's go. Count recipient amount and fees. Amount fees. Symbol will be hard coded.
Most people can't even decide what color to wear or which burger to eat. What the does it matter, man? Autonomy is an illusion.
This song is so good.
Autonomy is an illusion. Autonomy is an illusion.
I got enough of every melody, they all sound the same. Yeah. For my broken heart, no remedy, but maybe if you stay, we can get away with it. 'Cause you make me love my imperfections, answer all my questions, just to show me what's on the other side of inhibition. No apologies, my baby. I do you do 'cause I'm feeling so good. Ooh. I do you do 'cause I'm feeling so good. Ooh. Oh, my darkest memories, now let me fall back. But you'll be there, ready to rescue me if I go out of track. We can get away with it. 'Cause you make me love my imperfections, answer all my questions, just to show me what's on the other side of inhibition. No apologies, my baby. I do you do 'cause I'm feeling so good.
Be right back.
Story stays with me like a haunting melody. What do spirits say? What do spirits say in the darkest days? What do spirits say?
back, and where's my glasses? Okay, where are we? Okay, so we're working on the prepare send transaction handler, and we want to send. This all looks good. We will try to send it, but before that, let's prepare ourselves to receive it. What just happened? There was a weird ending to the song. Alright, moving on. Where were we? Add account, generate address. Yes, over here. No, not here. Over here. What's response that we're using here? Generate a response. Okay. Assign that here. Read the body, and let's send a request so that we have the JSON. What? Why is that not working? Seems to be doing something, but it's not showing up in my network stack. How about the backend? Does it show up here? Nope. It does show up in console. So, what is going on? Prepare send transaction. Did I plug it right? Prepare send transaction. Yes. Account ID and amount is being. Oh, I just need to reload it. Select address. Lol something something. One address as and fees. Oops. Or set it. Okay. Hang on. There you go. Let's restart the server. Send again. What is null? And where is this console.log coming from? I thought I have removed it. To pay some transaction. Over here. 192 and 189. Oh, the previous code. Don't need this. Thank you very much. Reloading again. Let's fill this out and then. Network error. Caught by this one, I think. What is the network error though? Oh, it didn't clear the course error. It didn't recover from that. What is going on? Doesn't pass access control check and is present at the requested resource. Let's try saving it again and compiling it. Now that it's running, let's try one more time. Same error. The options request actually is a 200, okay. So I don't understand. It says pre-flight options request, which goes okay, and this one fails. What in the world? Why is this happening? It's exactly the same request that we handled earlier, and even this code is simply copied over from that section, so I don't follow why it would return an error. Has been blocked by CORS policy, response to pre-flight request doesn't pass access, no header is present. So let's check the response headers. Why is there no header here? It should have an header. So when the options request does come in, it says all these headers. For some reason this doesn't show up there. Alright guys, that's it for today. I'll go get my dinner and we'll resume the same. So all the progress that we made so far, that was good for today. We'll continue from here tomorrow, and Yeah, thanks for watching. Thanks for tuning in. And if you like what you see, then give me a follow on Twitter. That's where I'm most active. And if you like this project, go to woodpecker.com, woodpckar.com, and drop in your email so that you can receive updates about the development of this project. So thanks. Thanks again. Bye bye.